All right, we're 1 minute past the top of the hour, and so we are going to get started. Thank you, everybody that has joined us. We are very excited for this webinar series, and we're glad you could make it. I'm Sam Bakken, Content Marketing Manager at NowSecure. Again, thanks for joining us for our webinar series, Mobile Penetration Testing, the Trilogy. This is the first installment. This is episode 1, entitled The Forensic Menace, as you can see on your screen. So real quick, I want to tell you a little bit about this series that we are producing. And so here you will see that episode 1 is the Forensic Menace. That's what we're talking about today. Today, Katie Stremka, our Director of Services, will introduce the series and dive deep into testing for exposed data at rest via forensic analysis. Then in the following 2 episodes, the next episode, I want to remind you, will take place next Thursday, and we'll share a registration link with you at the end of Katie's presentation. During the next 2 episodes, you will be hearing from a couple of our other experts who specialize in the areas of network and back-end penetration testing and reverse engineering Android and iOS code. I just want to say real quick that we want this series to be interactive, so I encourage you not to not be shy about submitting questions to the host using the chat function in the GoToWebinar interface, and we will answer your questions at the end of the presentation. So really quick, I just want to remind you of a couple of ways to get more information from NowSecure, about mobile app security and mobile security in general. So you can connect with us via Twitter there. Subscribe to our weekly digest of mobile security news by visiting mobsec5.nowsecure.com. And then also, of course, you can take a look at all of the wonderful resources we have hosted on our website at nowsecure.com. Now, I want to introduce you to today's presenter, NowSecure Director of Services, Katie Stremka. Katie directs the NowSecure Services organization, is co-author of the book iPhone and iOS Forensics, and is a recognized expert in mobile forensics and app security testing. Katie holds a master's in cyber forensics and a bachelor's of science in computer technology from Purdue University. And Katie was also recently named by Crain's Business Daily as one of the top 50 technology people that you need to know in Chicago. Among her other duties at NowSecure, Katie handles our penetration testing engagements with clients, oversees our testing methodology, process, and then report development and delivery, and she also manages a high-performing team of mobile penetration testers. So without further ado, I'm going to hand it over to Katie.
Thank you very much, Sam, for the introduction, and welcome everybody to episode 1 of our 3-part series. Today we're going to start off with an introduction of the different areas of analysis as it relates to mobile app testing. We're then going to dive deeper into data at rest in particular and show some of the common areas on both iOS and Android where data is stored. Before we dive into analysis details, I did briefly want to cover a couple of important prerequisites before getting started, with one of these being an analysis checklist. A checklist for mobile app testing is important as it not only provides consistency in process and results across your team members, but it should also be thought of as a minimum baseline for security testing. So in other words, you should at the very least cover these items that are contained in your checklist, and as your team grows, you'll then have this as a reference point that all analysts can revert back to in order to make sure you have the minimum coverage necessary. When it comes to creating your internal checklist, you should consider what's important to your company, especially as it comes to things like risk and compliance. For example, coverage of internal policies is always important, as are industry standards such as OWASP Mobile Top 10, and on the government side, if you map to NIAP standards, that's also important as well. So when creating and maintaining my team's internal process, I like to start with high-level categories, which we're actually going to cover here in a couple of slides, and then I break them down into categories. I break down each category then into very specific tests. The third bullet point here is equally as important as the first 2. So it's also important to note that while an analyst should cover these checklist items at a minimum, a mobile app will always be vulnerable to human ingenuity. So always allow your analysts, or yourself for that matter, some leeway to get creative. Let's take the checklist one step further and talk about how you actually implement it and make sure that people are using it. To do that, it's important to develop a repeatable process that works for your team. This process should include establishing testing requirements so that your security analysts are all on the same page. These testing requirements can also be used for things like onboarding and training new team members. And at the same time, a set of testing requirements will also set expectations up front for your developers so that they have an understanding of what security vulnerabilities to avoid when developing the apps. And your process should, with the help of your checklist, ensure full test coverage and allow for things like repeatability and consistency in reporting, which are crucial as you scale your mobile app environment. Waiting for that to switch. There we go. So when assessing the security of a mobile app, I like to say that you should cover 4 main areas of analysis. Here we break them down into forensic analysis, so ensure that data at rest is stored securely, and that's of course what we're going to be covering in today's episode. Category 2 is network analysis to ensure that the data is transmitted in a secure manner and is encrypted when going to and from the app in the backend server. The third part is the server-side penetration testing to make sure that the backend components are properly secured and sensitive data can't be accessed in that manner. And finally, the fourth area is reverse engineering and code analysis. So the native code should be reverse engineered and analyzed from a black box perspective to ensure that code cannot be manipulated. Each of these areas are really critical to ensuring full coverage in your mobile app testing. And we always talk about mobile is unique in that there aren't many tools available that cover all of these areas of analysis. So typically you'll find tools that are focused on just one of these areas or maybe 2. So it's important to identify a tool set that ensures full test coverage on all of these areas. The same is true for your security analyst as well. Your typical forensic analyst that focuses on that area isn't going to be an expert in network pen testing necessarily, just as your expert code hacker may not have a complete understanding of all of the possible areas on a device that sensitive data can be stored. So in today's episode, we're going to be focusing on analysis of app data at rest. We'll be talking about common areas to find sensitive data, as well as a couple of examples on how to recover that data and some key things to keep an eye out for. This first slide here is just a good graphic to cover the most common areas where we find that mobile app data resides. I'm going to go through these briefly and then we're going to get into them a little bit more detail throughout the rest of the presentation here. So starting on the left and going down, the obvious one is the private application folder. This is the folder that gets created every time you install an app and use it on a mobile device. And this is true for iOS and Android. Each app has its own private app folder where data is stored in files here. Next is SD card. So on Android, there's either the external removable SD card or emulated SD card, but this is another common storage location specific to Android where things can be accessed. System log files applies to all platforms, and these log files are generated not just specific to a mobile app, but for the device itself. So things like error logs are stored here. And what we find is that during development, a lot of developers will enable logging and debugging to track issues. But we've also seen it where developers will oftentimes kind of forget to toggle that back off when the app goes to production. And so we oftentimes find a lot of sensitive app data stored in system log files. Jumping over to the top right there is keychain on both devices, especially, iOS keychain has been around for a very long time and is a popular place to store sensitive data like user credentials and passwords. RAM is another area it's less focused on usually because it's where data is temporarily stored. When a device is rebooted, data gets wiped here, but it's another area that we like to focus on because the idea is that when you sign out of an application or if there's a session timeout, it's expected that sensitive value should automatically be cleared out by the app as well. So that's another area that we like to recover data from and test for. The next one on the list is source code. So values that are hard-coded in the app itself that's residing on the phone. We've seen sensitive passwords and other values hard-coded there. So that's where code analysis comes into play. And the last one on the list, I always like to point out, even though it's not as common anymore, is web cache or web history on the phones. So this was really common back when we would test web apps more often than native apps, or now we still see some hybrid, or people call them web wrapper applications, where it's a combined native and web app in one. So whether the app opens it internally or if it navigates the user out to the Safari browser or the Chrome browser or whatever browser you're using on your phone, the web cache is another common area that you should look at. It's important to note that standard mobile forensic software alone will not recover data stored, will recover data stored within the file system on a device, but it's not going to be able to recover all of the areas we just discussed on the previous slide. So for example, decryption and analysis of the iOS keychain, or recovery of syslog files, or extracting the voluntary memory that we just talked about will likely require additional manual tools and steps. Most open source tools, if you haven't used them, they do require command line knowledge, and some of them require a lot of manual steps in order to achieve the end result that you're aiming for. So it's really important to test out various options, as the wrong set of tools can lead you down a very time-consuming and tedious path. But on the other hand, if you have the time to learn and to tinker, they can also be really great training resources. I wanted to quickly show this slide, and this is more, remember that you'll be getting these materials after the webinar is over, so there's a lot of slides where we have links and other tools embedded here for you. But in this slide, we simply wanted to share out a few links to specific tools that can be used to recover data from each of the common areas that we've talked about. And like I said, we'll make sure you have access to all of these materials. And please keep in mind, this is not an exhaustive list, but if you have questions on other tools that don't fall here, we're happy to help point you in the right direction. As a mobile security analyst, it's not only important to identify a vulnerability in a given application, but also to assess the risk that the vulnerability will be exploited. Your development team, for example, is not going to spend months rewriting an application just to fix an issue where the likeliness of an exploit is really low, but they will for highly visible and common vulnerabilities that handle sensitive data. So when assessing risk, it's important to take things into consideration, such as how sensitive is the data that you were able to access, how likely is it that a malicious actor could get access to that data, and would someone need physical access to the phone, or could this be done remotely? Using our data at rest examples from earlier, data stored on the SD card is definitely a higher risk than data stored in the private app folder, since other applications have access to the SD card. The third bullet on the list here is a suggested area to focus on. So CVSS, the Common Vulnerability Scoring System, is an industry standard and a commonly used scoring system for vulnerabilities. And recently, within last year, it's been adapted to have more of a mobile focus as well, as opposed to just a general security vulnerability for web app focus. Okay, so we're now going to take a look at a couple of brief examples that we're going to step through on how to manually recover data from both an Android and iOS device, starting with Android. I just want to say that because this is a very command line heavy exercise, and I don't want to bore you all to death on this webinar reading through each detailed step, I'm going to be talking through these steps at a high level, but we made sure to include the links and the full commands in these slides if you wish to run through these tests at a later time. So starting with requirements, I like to kind of set you guys up so that you'll succeed in running these tests. We make two assumptions here. One is that you're using a rooted Android device with a USB cable. We're going to be using a Nexus 5, but really any Android device that can be rooted should work here. And the second is that you have a Linux machine, a Linux system or virtual machine that has Android Studio tools installed. We link out to our Santoku Linux, which is a freely distributed virtual machine that we've basically taken and combined all of the mobile forensics and security open source tools in advance for you. So once you download the VM, you should be all set up and ready to go. This slide is just kind of a repeat of the common areas that we talked about earlier, but specific to Android. Once again, private app folder, SD card, log files, RAM, source code, and web history are common areas to find app data at rest. And in this example, we're going to quickly walk through here. We're going to be pulling the a specific application's data from the private app folder in the SD card. Once again, you're going to be seeing a lot of screenshots here that show specific commands. I'm not going to walk through each of those commands, but we'll talk through these steps at a higher level. So the first major step, locate your app. For the Android commands we're going to be using here, we're going to be using something called Android Debug Bridge, so the ADB command. That's really just a way to shell into the Android device and connect to the file system there. So in order to locate your app, you're going to access the device shell and change into the data directory. The data directory is where all of your installed apps are going to appear. And here you simply want to find the app's private directory, so the package name. In this case, we're looking at the any.do application, so you can see in that third screenshot, com.anydo is the one we're looking for. And that's just something you want to take note of for the next step. Step 2 is pulling app data off the phone. Once again, we're going to be using the ADB command, ADB pull, I should say. And here you're just going to type in ADB pull, give the path to the data source and the path to the destination. This will work for both the app folder and the SD card location. So as you go through this exercise later, if you choose to do so, you'll see the very specific commands that we entered. Feel free to follow along with that. But running this command twice, once for the app folder and once for the SD card, should pull that application data from the phone into the folder on your computer that you specify there in that command. The third step is, of course, analyzing your data. So the fun part about forensic analysis is that it does take time. So there's a lot of files that an application will store in these areas. And it's really just a matter of using searching tools or looking through the databases and the XML files and trying to find sensitive data that you're looking for. These screenshots here show this particular application's data files, just a few snapshots of them. I'm not going to go through those in detail right now, but at the end, once I finish the iOS example, I'll talk about common ways that apps store data, or common file types, I should say, and we'll talk through those. We're going to go through an iOS example now, and then again we'll talk about analysis of the data on both platforms. So system requirements for iOS, jailbroken device. There's a jailbreak available through iOS version 9.3.3 as of today. So make sure you're running a phone that's that version or lower. There's no jailbreak available yet for iOS 10. Once again, for this example, we'll be using a Linux virtual machine. We recommend Santoku. It's already pre-installed and set up for you. And then there's a third step for iOS. It doesn't have something very easy like ADB. So we have to basically set up a remote SSH connection in order to run these commands. So we linked out to some instructions there for you if you choose to go through that process. This slide, once again, we're just going to quickly cover the areas that are specific to iOS. There is a lot of overlap between Android and iOS, with things like the iOS keychain being a key difference. But in this example we're about to go through, we'll be covering just pulling data from the private app folder. Locating your app on iOS, an application will store the app bundle, so the IPA file, the actual application, in a different location than it stores the actual data. They decided to do this in, I think, iOS 7 or 8, which just made things a little bit more confusing, but we're going to be focusing mostly on the data anyway. These commands here show you exactly the locations that both of these are stored, and the idea is that you want to, of course, find your application that you're going to be focusing your analysis on. Another difference between iOS and Android, is, as you can see in that second and third screenshot, is that iOS does not simply name its application folder any.do. So it's a unique random identifier there, and so it takes a couple more steps to identify the app that you want. In this next slide, that's step 1, continue to locate your app. I give some recommendations on how to find the app that you're looking for. I like to sort by the most recently installed, dig into that top folder, and then I show a command there to basically verify that that's the app you're looking for. This is a very long, unique identifier, so the next recommendation I have is to make note of that full path from the previous step, because you're going to be using it to copy the data off of the phone. We used SCP for that, and so the second step here on this slide, we used the secure copy command to copy files from the device over to your computer. Very similar in format to what we did for Android, where you're running the SCP command. You get the source, so the path on the phone to what you want to pull off, and then the destination, which is the path to the folder on your computer where you want the data to be stored. Again, so analyze app data is the third, and that's a very open-ended slide. I do realize that. So you're going to again get a list of folders and files that you have to dig through. In this next slide here, I'm going to give some pointers to keep in mind during your analysis of these files. So the first being that there are some common file types that you'll want to focus on, and more importantly, make sure you have a favorite viewer available for these file types. So SQLite databases is extremely common. Find a SQLite database viewer that you like and use it. plist files are specific to iOS. They're essentially XML files, which you'll also see on Android. These are also very common, so finding viewers for these file types is going to be helpful for you. Moving directly to the right, when searching for data in large files, I like to use command line tools. So for things like memory analysis, or if you have just a really large file, opening it in a text editor will oftentimes crash the text editor. So I like to use grep, which is a command line tool that we link out to search for sensitive values in it. It's unrealistic to take a very large data file and look through every single word in it. So try and pick things like user credentials or account numbers or sensitive values that you care about when looking at your application, and search specifically for those. Directly to the right again is iOS apps in particular. I wanted to call this out because all iOS apps as of iOS 6 or 7 create a cache.db file. And this is a default action. So in order for a developer to not store app data here, they have to specifically disable it. So very often we will find that iOS apps store data in this file. So keep an eye out for it. It's in the caches directory once you've pulled the app folder off. Next is be sure to look for not just plain text versions of the keywords you're looking for, but it's very common for apps to store data as common hashes or encodings. So base64 is a good one to look for because it's so easy to decode. It's essentially storing data in plain text. So keep an eye out for base64, MD5, SHA-256, and other common ways to convert sensitive data and hide it a little more. And last but not least, I know this is kind of general, but don't limit yourself. So explore storage locations beyond the ones we discussed today. That goes back to the checklist. Explore things that aren't on a checklist because that's where you're going to find the biggest issues most likely. From when there's a new iOS version released, Apple has the free reign basically to change whatever they want from iOS version to iOS version. So things that are true today may not be true tomorrow. So just keep an eye out for new updates in iOS versions, and that goes for both Android and iOS. All right, I want to quick wrap this up in some takeaways for episode 1. We talked about creating a checklist and documenting your process, which is helpful not only for your security teams and for yourselves, but for your developers as well to set expectations. Assign responsibility for various test coverage areas. Like I said, it's rare to find a single person that has the expertise in all 4 of the areas we discussed. So, make sure you assign the forensic analysis to the person that's responsible for that and divvy those out within your team. Selecting the right tools Oops, I forgot to advance the slide, sorry about that. Selecting the right tools to find and test for insecure data storage is important, so play around with different open source and commercial versions to find what you like. Looking for data in common areas that we discussed earlier, but not limiting yourself is also something to keep in mind. And again, very important for a security analyst, if data is found, determine its value and assign risk so that everybody can be on the same page of the priority on what to remediate.
Katie, thank you so much. The audience, I'm sure, was just, there was so much information to take in there, and that's great. So thank you for that. Really quick, while Katie gets kind of situated on some of the questions that have come in. One, I want to remind you that you've got a mobile penetration testing expert on the line right now, and you should be submitting questions right now in the chat function in GoToWebinar, because she's on the line, we've got her here, and we can get those questions answered for you. Thanks to those of you that have already done so. The other thing I just want to remind you of again is this is just the first of the mobile penetration testing trilogy, okay? So this was episode 1, the Forensic Menace. Episode 2, Return of the Network Backend, is occurring next Thursday, December 15th, and that's at 1 p.m. Central, same time. And you will receive information about how to register for that in our follow-up communications to you. But I also wanted to give you the link right here on this slide in case you really wanted to sign up right now. So with that, thank you again, Katie. I am going to now start asking some questions of Katie that have come in. We're getting some good ones. Keep them coming. So first, Katie, I want to ask you this question. How common is it to find app data in backup files?
Very good question, and it's very common. So I'll start with iOS in particular. That's actually something that we have as part of our checklist. We'll do a backup of the device and see if app data is stored there. On iOS, we just simply use an iTunes backup, and that typically includes a majority of the files that are stored in that private app folder. There's only one subdirectory that's usually not included. So yes, it's common. On Android, I think that the device has to be rooted basically to get access to the app folder, but there's definitely ways to recover app data from that location.
Very good, very good. Thank you. You mentioned something that's relevant to another question that was asked, so I just want to get that one, ask you that one as well real quick. Do I have to have a rooted or jailbroken device to perform any sort of penetration testing of an app?
Have to? Yeah, I'm going to say yes. I was going to say no, but strongly recommended. But you know, the point of this is to test the app. You're not testing the security of the device or the security of the operating system that you're running in. We're trying to test the security of the application. And to do that in the most thorough way possible, you should have a jailbroken or rooted device. Otherwise, you'll be really limited in what you can test for. And again, the idea is to test the security of the app so that once it's out in the wild, it's fair game. So you have to assume that someone does have a rooted or jailbroken phone and can get access to that data. So yeah, I strongly recommend a rooted or jailbroken phone. Otherwise, like I said, you're limited to only certain areas of the device that you can test.
Let's see. The next question I want to ask you is, so this is a very specific question, but I think it's also a decent question. I'm going to generalize it a little bit. But do you know of good examples of vulnerable applications to practice on? And after you answer that, then I'll get specific with this individual's question.
Yeah, so there's the common application out there, the Diva app, DVIA, which is something that customers ask us a lot about, and that's a really great application when it comes to learning how to do mobile security app testing, because it basically requires user interaction with the application to cause vulnerabilities. So one example would be, click this button in the app which enables device logging or app data logging. You'll then do the app data log recovery test to check for that. So that's a really good example of a test application. It's hard for me to not name ones that I know of in the App Store because we can't publicly disclose things like that, but we're also in the works of developing internally a practice iOS application. I'll have to check with our team and see if that's ready to share out yet. I'm not sure if it is, but we can also share that out as well.
Awesome. And then just specifically, I don't know if we can answer this quite yet, but is there a vulnerable hybrid mobile app that can be tested, or is that tough to say?
That's tough to say. We see those again from our customers that submit apps, but those are obviously not things we can share out. I will take that as a follow-up to look into and see if we can find an example of that and get back to you.
Very good. Now this one goes a little bit toward your experience as an expert witness, perhaps, and also your schooling and all of the forensic investigations that you have conducted. So if I rooted a cell phone, could it be considered modified evidence on a forensic investigation? Does that question make sense?
Yeah, that's a good question, and that was back in my forensic analysis days. That was a very common debate. I think there's a really good answer to it. Yes, technically it does change files on the phone in order to get access to the data that you need to analyze in order to do your investigation. I believe it's a very common technique now for that forensic tool, not just I believe, I know forensic tools today use that as a method to get access to data. And it's important to remember or to know exactly what a jailbreak does so that you can explain that if you ever have to testify. But technically, yes, it modifies files on the phone, but is it going to modify the text message that somebody sent? 99% chance no. Almost 100% chance no. So just making sure you understand what happens when I install this jailbreak exploit on the phone so that I can explain that. Is really the approach that you'd want to take. You don't want to say, I clicked this button in this software to get access to the phone. You want to know exactly what that button did.
All right, we're getting close to our end here, but I do want to ask a few more because people are asking, and I encourage people to continue to submit those questions. So this is getting a little specific again, Katie, but I'm sure you have something to say about it. How to decrypt or crack the DB file if the data SQL database, which is encrypted inside /data/com, package name and Android. Does that make sense what I just
Yeah, that I wish I could answer that in a couple sentences for you right now, but there's unfortunately a lot more to it than that. SQLite databases are a very, very common storage location for all app data. Sometimes applications will take the extra effort of encrypting it. I guess the first area I would point you to is SQL Cipher is a common way that developers will use to protect that data. So if you do some research around SQL Cipher, if you find that cipher key, you can decrypt it. That's just kind of a guess off the top of my head. There's so many other possible encryption methods that people could use. They could be custom, it could be something that's well known, and unfortunately without actually analyzing the application, I couldn't give a more specific answer than that.
All right, I think I'm going to try to pick two more because we should cut this off at about 1:45 p.m. Central. Here, hold on. Katie, we are just getting a ton of questions, which is awesome. This is so great. Again, this is going back to kind of what you talked about, the first question, but is there any method by which analyzing data at rest can happen with unrooted phones? Is there anything you can do?
Yes, but again, very little. So you could do a backup. You can do a backup of the phone and see what you find in the backup files. Things you can't do, decrypt the iOS keychain to see if sensitive data is stored there. You won't be able to get access to everything stored in the application folder because, like I said, when you do an iTunes backup, for example, it's going to be missing certain files. Syslog on iOS you can't do without a rooted phone. Memory dump you can't do without a rooted phone. So all of those common areas that we talked about earlier, there's really only one or two that you can partially do with an unrooted phone. So yes, there's a couple things, but to really get a full analysis, you definitely need to get jailbreak or root access.
Okay. Here's another one. Forgive my ums here. I'm working on that. That's a personal goal of mine for 2017. Say less. Now, how do you do cross-site scripting in mobile apps?
Sure. So that's another question like the encryption one where, again, I wish I could give a quick short answer here. When it comes to how to do this kind of stuff, there's multiple day and week-long trainings that cover these things. So cross-site scripting is an example of a category that we would talk about in our network and web services / server-side testing. We likely will not cover that attack scenario in next week's webinar, but we can probably point you in the right direction to some resources that cover that. I know that's not a very detailed answer, but again, it's one of those things that would take more than just a few minutes to give a how-to on that.
All right, and Katie, I'm going to ask one more question, and I think this kind of leads us into next week's episode. So, if credentials are stored locally for offline access, what are the means by which that can be exploited? Like authentication bypass without credentials. First part of the question probably not relevant to next week's episode, but the second part I think might be. Anyway, that's the question.
Sure, so that is an it depends, and it depends on where the credentials are stored. If they're stored in the keychain, so the means by which that can be exploited. If it's stored in one of those areas, which it has to be, that we covered earlier, then they'll be able to be retrieved. It's just a matter of what's the level of effort that it takes to retrieve them. So again, if they're encrypted in the keychain, that's an extra layer of complexity that protects those values. So I would consider that a lower risk. Authentication bypass without credentials usually requires some kind of technical knowledge when it comes to reverse engineering apps and doing things like runtime analysis. We have seen apps where, because of local authentication, our team was able to use a tool called Cycrypt, which I'm very confident will be covered in our code analysis and reverse engineering episode 3. But they can use Cycrypt essentially to bypass that authentication and get access to the application. This is not common, so if your application allows for this, it's probably not a good thing. But again, these are things that require some additional knowledge on that type of analysis.
Great. Thank you, Katie. I think that I am probably going to wrap this at this point. Thank you, everybody, for the questions that you've submitted. And Katie, I don't know if there's anything else you feel the need to kind of state here before I wrap it up.
No, I don't think so. Other than, we had 30 minutes here. We went past about 15, but we didn't have a lot of time to dig into something that takes a lot of time. We used to teach forensic analysis courses back in the day, and I would teach a full 8-hour day on just iOS analysis, a full day on Android analysis, and that was just the data at rest. That didn't include all the other areas of test coverage that you need to include for app testing. So if anyone's feeling overwhelmed because this is a lot, just take it in stride. There is a lot to cover, and starting with something small and building your way up, asking questions, looking for resources online. OS Mobile Top 10 is a good one. That's a good place to start.
That's great, Katie. So again, as Katie mentioned, I want to remind you that this is a trilogy. There are 3 parts to this. Today was just the first episode. Again, next week, Thursday, December 15th, we will be diving deeper into mobile penetration testing, specifically thinking about network communications, and then also back-end services. All, of course, though, in a mobile context. So I encourage everybody to join us for that. The registration link is there on your screen, and you will also receive some information about how to register with our follow-up communications about this webinar. So again, Katie, thank you so much. Audience, everybody that's here, thank you for joining us. This was really great. We got a lot of questions. It's a very interactive session, so we thank you. And with that, I'm going to wrap it up. So thanks, everybody, and have a good rest of your afternoon.